what's up guys? I'm Andrew, and today we're going to be going over the physics of friction between book pages. First, we need to understand how friction works. Friction is basically the resistance created when two surfaces slide across each other. It's given by the equation frictional force equals normal force times the coefficient of friction. Let's take two examples. On this side, we have cleats going against grass, and on this side, we have a hockey puck going against ice. Which two of these scenarios seems like it'd be easier to slide? And obviously, you're going to choose the ice. This is because the coefficient of friction is lower on the hockey puck and the ice, and it's basically how rough both surfaces are when they slide across each other. The other factor we need to take in is the normal force. Normal force can be described as the opposing force to forces like gravitational force and other forces. Geez, that's a lot of information, but that's all necessary to know our driving question. How many pages between these two books need to be interlocking in order for one to hold the other? Let's get into it. Sadly, before we can put the pages of the books together, we need to get some common misconceptions out of the way. How come when more of these post-it notes are overlapped, they have a higher frictional force? Some people believe the weight of the top post-it note pushes down on the ones in the middle, increasing the normal force. However, if we turn the post-it notes vertically, the pages are all equal in height and not weighing down on each other, and they still won't pull apart. The second misconception is that an increase in the overlap between the post-it notes will result in a greater frictional force because of the larger surface area for the pages to grab onto each other. While it is true that a greater overlap will result in a higher frictional force, it is not because of the amount of surface area. It is actually due to the angle created when the pages overlap. As you can see here, the farther the pages are pressed together, the larger the angle created. And with this larger angle, there becomes a vertical force facing into the middle of the pages, and thus a normal force facing out. And obviously, with an increase in pages, this angle also increases. So now we know the physics behind the friction between book pages. Let's figure out how many pages need to overlap between this book and this book in order for this one to not fall. We just found the answer to our driving question. How many overlapping pages between two physics textbooks does it take for one book to hold up the other? Turns out it's 103 pages. Very interesting. But we can go a little further than that. We know that gravitational force equals frictional force. Gravitational force is given by mass times gravitational acceleration, and frictional force is given by the coefficient of friction times normal force. Now we know that the mass of the book is 2.25 kilograms, gravitational acceleration is 9.8 meters per second squared, and the coefficient of friction between paper is around 0.1745. And then if we set normal force equal to gravitational force divided by the coefficient of friction, we get that normal force is 128 newtons. And this is around the same amount of force needed to press a 25-pound dumbbell above your head. And this force is pulling on the pages of the books out, kind of like a Chinese finger trap, and that's kind of what holds together. But I hope you enjoyed the video, and if you want me to cover any more physics topics, I won't be doing that because this is a school project. Thanks for watching.